today's lesson, we're going to be looking at pseudocode. So what is pseudocode? Well, pseudocode is an easy-to-read coding language that can't be used by a computer, but can be easy to follow for humans to check and make sure the program will work before writing it into a specific computer language. So there are different computer programming languages that you might use. There's Python. There's a very basic form called Scratch that we're going to be using. I think LaTeX. There's another one. There's different computer programming kind of languages that you might be able to use. But pseudocode is basically just kind of taking that code and just putting it into more simplified instructions or steps that makes it easier for us to follow if we don't know the specifics of the specific coding language. So some common notation that you might find. So for example, we might see things like input, which indicates a user will be inputting something. Output or print indicates that an output will appear on the screen, right? It goes through the code and it gives us a result. Set means to assign an initial value to an expression or to a variable maybe. If, then, else, this is a decision or a selection in which a choice is made. So for example, if something happens, then this, or else this. Usually any instructions that occur inside a decision are usually indented. So these are just some common things that we might see. So an example might be in pseudocode in red. Start, set A equal 2, set B equal 3, print A plus B, end. So that's our pseudocode. So what is the output of this code? And so what do we have to think about? What are the steps of this code? Well, we have to set A equal to 2 and B equal to 3. Then we have to, or basically our code is saying substitute or let A plus B or add A plus B together. So let A plus B become 2 plus 3, then display the result. So if we go through this step, A plus B, we have 2 plus 3, 2 plus 3, this equals 5. So that means 5 would be the answer or the output that is printed. And so that's an example, that's a very basic example of what pseudocode is. If we're making a decision between two alternatives in code, then we use the if, then, and else statement. So for example, start, set A equal to 8, set B equal to 5. It's the same kind of thing before. If A is greater than or equal to B, then print A, else print B, end if, and then end. So what is the output of this code? So the steps we're doing, we're setting A equal to 8 and B equal to 5. Then what is happening? Well, then the code is saying we have our if statement. So if A, which is 8, is larger or greater than or equal to B, which is 5, then print A, which is 8, otherwise, which is the else, otherwise print B, which is 5. So since we have our if statement, right, we have is 8 larger than or equal to 5? It is. In that case, we are going to print 5, right? Or sorry, print 8. So our output will be 8. So 8 will be our output. The end if, right? We have two ends here. That's basically just ending that if statement, right? So if we wanted to do something else after that or include more code, it wouldn't be part of that kind of alternative or decision making. So let's kind of go through. Look at the pseudocode below and think about what value would be printed, right? Or what output would be given. Right, so we start. Set A equal to 73, set B equal to 44, set C equal to A plus B, and then print C. So in this case, what's happening is we have A equal to 73, B equal to 44, and we're saying C equals A plus B, which means that C would equal 73 plus 44. So we'd get an output for C of 117. So that would be our output. We would be given that answer. We would have an output equal to 117. That is what this code is going to give us. So all it is just kind of taking a math problem or an equation or a solution and just putting it into a step-by-step instruction. Right, so look at the pseudocode below. Again, same idea. Start. Set A equal to 8. If A divided by 2 is an integer, then print A is even, else print A is odd. And if, end. So again, we got to think about what is our code asking us to do. Well, the set is straightforward. We're saying that A is equal to 8. And now we have a statement. If A divided by 2 is an integer, we say if it's even or odd. So we need to know what an integer is, right? And an integer is a positive, negative, or zero whole number. Right? So if we get any sort of decimal in our answer, when we take A and divide it by 2, we don't do anything. There is no answer. So in our case, 8 divided by 2 equals 4. So 4 is an integer. Since that is the case, then we can then print one of our two options. Is A even? Or is A odd? Well, it is an integer, and because it is even, we can put, this would be our answer, right? This output, A is even, would be the output that is printed. Consider the rectangle shown in the image. The dimensions of the rectangle, W equals 3 meters and L equals 6 meters. What does the following pseudocode calculate? The pseudocode is start. Set W equal to 3. Set L equal to 6. Set A equal to W times L. This little symbol is just multiply. Set W times L. Print AM squared. End. So it's telling us to let W equal 3, L equals 6, and then we're using a formula, A equals W times L. So in this case, what is it asking us for? What is it looking for? Units? Is it looking for volume, area, perimeter? And if we remember, looking back at our measurement lessons, area of a rectangle is length times width, or W times L, or L times W. So that means this code is going to give us the area. And if we wanted an output, it would print something with meters squared, in this case 6 times 3, which is 18. So it would give us an output of 18 meters squared. So an example from EQAO that you might see, there are pseudocode questions on EQAO. So output, enter width, store as W. Output, enter length, store as L. P equals 2 times W plus 2 times L. Output P comma, centimeters, or cm. What will be the final output of this program? So the output is saying it's asking for enter width. So you get kind of like maybe like a speech bubble. This is enter width. Kind of a speech bubble or instructions. So basically we'd say enter width, store it as W. So saying W equals 4. Then we're going to be told enter length. L would equal 3. So we'd store that. Then we do P equals 2 times W plus 2 times L. And it would go through and calculate 2 times 4 plus 2 times 3, 8 plus 6, which would give us 14. So the output would be 14 and then centimeters. So the program would only give us one output or one kind of sentence. The math going on behind it is what we kind of calculated off to the side. So that's an example of basically what pseudocode is. Now what we're going to do is we're going to look at kind of taking that pseudocode and putting it into Scratch. And Scratch is one of the programming languages. It is a very basic starter one. It is kind of a drag and drop programming. So if you don't have any expertise in programming or coding, Scratch is a very good way to kind of start. So start, for example, a pseudocode might look like this. Number equal, user inputs a number. Step 1 equals 4 times number plus 13. And then display step 1. How could we write this code that would look like a mathematical equation if the input was 5? And what would it display at the end? Well, we have basically our steps. So we have our number. So number is equal to 5. So that means our step 1, or unknown, is equal to 4 times that number, or 4 times 5, plus 13. So we go through and we calculate this. We get 20 plus 13, which is 33. So that means that the display would show us 33. That would be the number in our display. So again, going through a pseudocode similar to what we've done before, or just did. So now what we're going to do is now we're going to go to Scratch and actually put in these different, or this pseudocode. So if you go to Scratch or search up Scratch coding, it will take you to kind of a main site that looks something like this. Right? You can just click, you could join, create an account to basically save your work, or you can just click on start creating and go right there. So we'll go full screen in a second, but what the first thing we have to do, the first step, is the variables in this code are number and step 1. We want to add these variables. So I'm going to go over to the little side. It's yellow. It says variables. I'm going to make a variable. So my new one, my first one will be number. Okay. And I'm going to make another one called step 1. And now what I'm going to do, now I'm going to go and build the following code. So this is what I want to build in Scratch. The nice thing is it's all color coded. So I believe the first one is a blue, or sensing it's called. You can see it says ask. So I'm going to drag that out here. I don't want to ask what's your name. I want it to ask enter a number. I then go down to my green, down to my red, or my orange under the variable. Right, so it might take a little while, but we want to set my variable. We want to change that to set number to answer. So I need to fill something into this box. So here it says 0. I don't want it to set to 0. So I'm going to go back to sensing, and there is a little shape that says answer. And I'm going to go drag and drop, and it goes right in. So it's kind of like fitting in puzzle pieces. I'm going to go back to variables again, set step 1. Change the drop down box to step 1. Now I need something green, so I need to go to operator. And if we see in our shape, we have kind of two green parts. There's one big one here and one smaller one here. So you want to be careful. So the first big one is we're adding two things. So I'm going to grab the adding operator, or adding two things together, and put drag and drop. I'm then going to take the multiplying one and drag and drop it into the first one. So wait till you see kind of that first part, that first little shape kind of highlight. Let me see if I can zoom in. All right, so I'll take it out. You see kind of how that, just that first circle is highlighted, not kind of the overall shape like there. So just the first part, put that in. I'm going to type in a 4 because the 4 isn't going to change, and neither is the 13. That's not going to change either. And then I'm going to go, the last one, purple, says look, and it's going to say, instead of hello, I'm going to go back to my variables, drag step 1 in, and that's it. So we should see our code over here. We see our little cat, our little character saying enter a number. So let's pick a number. Well, actually it might ask, or no, it doesn't ask us number. So let's pick a number. Well, let's try 5, see if that works from the last one. Ooh, just looking at it, I'm missing something. If I go back, I'm missing one of the variables I needed to drag and drop. There. Now we're done. Everything's filled in. Everything has something in the spot. So now we can go over and run our little program. So let's enter 5. I'm going to hit enter. And we get 33, which is what we got in our last one. And we can start and we can go back again, I think. So we can try a different one. Let's say 125, 513. So 125 times 4 is 500, plus 13 is 513. So this code will now work for any number that we type in. Let's try something just for argument's sake. Something very large. We can see up here what our values are, what the variables are, because we set them here. We could take them away if we really wanted to, but it's nice to see what we entered. So if we want to double check our work with a calculator, but we would find that we do get the same answer. So that is the first code. Let's go to another one. Number equal user inputs a number. Step 1 equals number to the power of 2. Step 2 equals 3 times step 1 minus 4. Display step 2. So can we write this as a mathematical equation? So this one's a little different because we have multiple steps now. Right? So if I wanted to, I don't have a number, or I do have a number, input number is 5. So if I number equals 5. Now if it was to do it step by step, then the next thing would say, okay, step 1, 5 squared, which is 25. Then step 2 equals 3 times step 1, which is 25, minus 4, so 75 minus 4, so 71. So in the end, we would get 71. If I wanted to write that as a single equation, right? It would be something like 3 times, instead of a number, we'll just say n squared minus 4. So that would be kind of an equation that we would use if we wanted to kind of run through this all at once. Right? We could do it step by step because we have the different steps, we have the different process from the pseudocode. But either way, in the end, we should get, in this case, 71. So let's go through and try to input that again. We're going to go back and we're going to change a couple things. I'm going to go back to my code. I'm still going to ask for a number and weight. I'm going to ask for that number. I need to make another variable because I don't have a step 2. So I'm just adding a variable, creating step 2. I am going to add something new. If I can find it under events. So it's a little orange thing. The colors might be a little off, but I want to put when the flag is clicked. So that means when I start up here, that will always be a way to kind of refresh. So ask, enter a number and weight, input or set number to answer, set step 1 to, we have to change. So let's take this out. Let's delete those 3 blocks. So we want to set step 1 to be number squared, or in this case, since there isn't a number squared, right, you are kind of limited, but we can do a number times a number. So we have the multiplication operator in now. Go to our variable, grab the number. We're going to take away the say for right now because we're not going to say step 1, so we can actually delete that. If we look at our blocks, we want to set another variable. We're going to set step 2. So click the drop down box. Set 2. We're going to have now 2 things. We're going to actually have a minus operator because we are subtracting in this one. So you start with the bigger one first. Again, hopefully you can see in the program or in our kind of note or lesson that we have kind of 2 boxes or 2 ovals. So then we're going to take the multiplying one. So 3, or type in 3 times step 1. So we're going to go back to our variables. Step 1 minus 4 will be our step 2. And then we want it to say, not hello, we want it to say drag our variable for step 2. So let's go through. So we click on the green thing, enter a number. We're going with 5 again, just to check. And we get 71, which is what we got when we calculated by hand. So I can go and click the green button again and start all this over. Let's try 250. Enter. 187,496. So we could go through that, check it with our calculator, and see if we get the same answer. And we can just keep on clicking the green button and going back, entering a new number, basically solving this equation or evaluating this expression or equation with any value. Part 2. So in this one, same idea. User inputs a number. Step 1 is the square root of a number. Step 2 is equal to step 1 times 5 plus 7. And then we display step 2. So what would be the input, or what would be the output when our input is 16? Right, so we can go through the same steps, right? Follow through. Right, so we have our number, which should equal 16. Our step 1 says let's square root that number. So let's square root 16. Square root of 16 is equal to 4. Step 2 says, okay, let's take the answer from step 1, multiply it by 5, and add 7. In this case, 4 times 5 is 20, plus 7, we get 27. Then we display step 2, so that means in the end we get something displayed of 27. So now what we want to do is we want to see if we can build this code. Right? So we're not going to be given the instructions, we're not going to be given the steps. We want to see if we can build this code from scratch. Now from scratch in Scratch. Now the nice thing is we have some of our code still from the other ones that we can use. So we still have the part for entering number. So we then want to enter number. We want to set that our answer to the number. Our step 1 is we want to square root a number. So how can we square root a number in Scratch? Because our operators are adding, subtracting, multiplying, or dividing. Well, what we could do, we can get rid of these. We can get rid of these blocks for right now, because we're not going to be using them, or we might not be using them. So for our step 1, how do we get the square root of a number? Well, if my number is 16, how do I get to 4? We need to figure out what two things multiplied by a number equal that value. And there is actually an operator. So if we go all the way down to the bottom, we see this one says something of. So let's drag that over. And if we bring that up, we see we have a bunch of different options. Absolute, tan, cosine, square root, sine, floor, ceiling, log, e to the power of, 10 to the power of. So these have a bunch of different math expressions or formulas that we might be able to use as well. So we want the square root of our number. So we're going to go back, we're going to put our variable of a number into here. We're going to find the square root of our number. That's step 1. Step 2 says we need to multiply step 1 and step 2. So if we want to, we can always do that separately. So we want to square root or multiply our step 1 by the value of 5. And then we're going to need to add that. So we're going to need to build into another operator. So I'm going to grab the adding one. Oops. Sorry if you can't see that. All we did was create our multiplying step 1 times 5. We're going to put that into an addition one because we're going to multiply this first. Then we're going to add. And we're going to add 7. And now this whole operation can go into our step 2. And then we want it to display step 2. So let's go and let's check. So if we go through, if we enter in 16, our little sprite or spirit, whatever they want to call it. When I enter a number, if I enter in 16, I should get 27, which I do. So that works out. So this code matches the equation that we've done. We can try other values. If we want to do a nice one, we can do 25. So 5 times 5 is 25, plus 7 is 32. Let's try something 200. So even if we have decimal numbers, it still works out as well. Right? We can try 15926. Right? So that is the nice thing, right? This basically is like our calculator for an equation. It does the entire equation or expression for us. So coming back, right, we were able to go through, build our code. Part 3, here is a code now. Right, we have the code on this side. Ask, entering number, and wait. Set number to answer. Set step 1 to number divided by 3. Set step 2 to step 1 times 7 plus 5. And say step 2. So we want to write what would the pseudocode be for this. Well, step 2. That first one is easy. We have our number user input to number. So that's this first part here. All right, so if we want to kind of pair things up, our display we're going to have here. So we need to display, we need to say step 2. We need to tell the program, or basically we're telling the program to display whatever step 2 is. So in our next one, let's go back up to step 1, because we're setting step 1 to number divided by 3. Let me say that, divided by 3. Oops. Let me say number slash 3. Basically, we're saying we're going to take the number and divide it by 3. Let's use the slash. Let's keep it consistent. So we're going to take our number and divide it by 3. Step 2 then is saying, we're going to take step 1, we're going to multiply it by 7, and then we're going to add 5. So really it's not much different than what's actually written in Scratch, because that is the nice thing about Scratch. It's very user-friendly, it's very basic, so it's very similar to what the pseudocode would be. So how would this look as a mathematical equation, and what would the output be if we displayed 4? Right, so you can go through and you could create this code and enter in 4 and then write out whatever that output is. But let's go through and write the mathematical equation, then we can always double check. Right, so we're going to say our number is equal to 4. So that means in our step 1, we're going to say 4 divided by 3. Well, that's a messy fraction. 4 divided by 3. Then step 2 says, okay, we're going to take 4/3. We're going to multiply it by 7 and then add 5. So here we get 28 over 3 plus 5. Let's work with the decimals because that's what Scratch is going to give us anyways. So 28 divided by 3 is 9.3 repeating plus 5. We end up with 14.3 repeating. And then so our display at the end should say 14.3. Might be 14.33. Maybe we'll do the repeating sign. I'm not exactly sure what sign it'll show. But let's go through and let's create the code. Let's recreate the code and see what we get. So number to answer, step 1, 2. Let's delete this. And we're going to put in a division. And we're going to go to our variables and grab our number block and say number divided by 3. I don't have to change too much in this one. I can just change my numbers, multiply by 7, add 5. Step 1 is in there, that's fine. Say step 2, perfect. I'm going to go to my cat. I'm going to start, and let's say the number is 4. We get 14.33, which if we double check, 14.3 repeating or 14.33. We can see in our actual steps, we can see the repeating 3s. So we know that it wasn't rounded. We know we created the right equation for this code. We understood the pseudocode. So again, very basic coding, basically telling step-by-step instructions to the program to calculate. Right. So part 4, what I want you to do is write your own pseudocode. Right, so come up with your own pseudocode, maybe add in a step 3, similar to what we've been doing, right? Not so much this one where we started with the code, but more so like part 2 where we had our pseudocode over here and then went through and then created the Scratch program to fix or to match that. Let me go back. Right, so this would be example. I want you to create your own one like this. Try to make it tricky. Try to add in a step 3, maybe even a step 4. But try to create your own pseudocode, then try to create that code in Scratch. Make sure you do the calculations if the input number was 10 so that you can compare that to the answer or the code that you build in Scratch and see if you get the same answer. To see either if your calculations are correct or if your coding is correct. But again, the main thing from this is just understanding what pseudocode is and how to read it. Right? Essentially, again, it's step-by-step instructions that walk us through like a mathematical problem.